Here we go. We're going to use the elimination method. And what that means is that we're hoping to eliminate all of our x's all at once. So here's my system of equations, equation number 1, equation number 2. We're hoping to do a method that's literally going to knock out all of our x's at once. Or if we can't knock out our x's, we're hoping to knock out all of our y's. And basically what that does is that frees us up that after we have eliminated one set of our variables, we could go and solve for that remaining variable. When you look at this, I'm hoping that perhaps you have an inkling about what we can do to eliminate these variables. And you could see right here that we could actually add the two equations together. 6x plus negative 6x would be 0x or nothing. Okay, so that would cancel out. But now we have to add the rest of our equations. Negative 4y plus positive 3y is negative 1y. And then negative 16 plus 18 equals positive 2. So that's our first step. We want to add or subtract equations. We don't always have to add. If this had been a positive 6 right here, I could have just subtracted the two equations and then, dealt with the subtraction here and here, and the result would have been different. Well, after you have eliminated one set of your variables, in this case we got rid of the x's, you need to solve for the leftover variable. So let's solve for this y, that's the leftover variable. Divide by negative 1, divide by negative 1, y equals negative 2. So that's fantastic. Here is our ordered pairs. The x should be in the first slot. We don't know what that is yet, but I know that the y is negative 2. So moving on, we need to go plug in the known variable, that's the y right here, and stick it into one of these equations and solve for x, kind of like what we did for substitution method. So here's 6x minus 4y equals negative 16. Well, this is a y. I now know that y is negative 2 in both of these equations. I stole the first equation, so this y is going to be replaced with negative 2. That y was multiplying the negative 4, so we'll put it in parentheses to show it should multiply. 6x minus 4 times negative 2. So we go through and combine like terms. In this case, we're going to have to multiply them together. That'll equal plus 8. We can minus 8, minus 8. 6x equals negative 24. Divide by 6, divide by 6. Suddenly we're left with x equaling negative 4. So this is negative 4. That is my solution to the SOE, the system of equations. Now, how do you know for sure if you're right? If you take these values right here, the x and the y value, and you plug them in to the respective spots, if it makes a true statement for both of the equations, you know you're right. If one of the equations or both of the equations comes out and something's wrong and it doesn't make a true statement, you've done something wrong and you need to investigate to see if you can find out what that is. However, here's the problem that's going to happen here. Occasionally you will go through, actually most of the time you'll go through and you'll say, okay, I can't do substitution, I don't want to deal with graphing, so I'm going to do elimination, let me just add them. And this is what will happen a lot of times. Well, let's see, this would be 4x and this would be negative 20y. Did we get rid of any x's? No. Did we get rid of the y's? No. It's not going to work. So then you come through and you go, well, let's try subtraction, because we can always subtract also. Well, negative 4x minus 8x is negative 12x. And negative 5y minus negative 15y would be positive 10y. And you still need to subtract there too. Same as with the add, you do all of the equations, but I stop here because you go, you know what? I didn't eliminate my x's and I also failed to eliminate my y's. So as a result, I'm stuck until I use this little trick. Notice that I said this is example 2. I need to change one equation. We can change both, but this is just an example where we could get away with changing one. Let's go through here and let's do this little pairing up move here. Here's my x values. This is an 8x, that's a negative 4x. If I can make this a negative 8x, I could add them, and that would make them go away. So if I could make that a negative 8x, life would be good. I could also make this a positive 8x, and if I subtracted them, 8x minus 8x, that would make them go away. If I look over here, if I could make this into a positive 15y, I could add it to the negative 15y, and that would make it go away. Or I could also go ahead and just leave this as a negative 15y. Negative 15y minus negative 15y would make it go away. So you have options. And if you determine what you would like it to be, if you can change it into that with multiplication, there's nothing stopping you. So let me go ahead and get a red pen here. I want to make this into a negative 8. So if I can make that into a negative 8, that'll work. What could I multiply negative 4x by to make that into a negative 8? Positive 2. 2 times negative 4x equals negative 8x. 2 times negative 5y equals negative 10y. And don't forget to do this one. 2 times negative 10 equals negative 20. A lot of times what I'd like to do is when I've changed just one equation, I like to write it right underneath the other equation that I'm not touching, because now I can go, cool, I can add it and be on my way. 8x minus 8x is nothing. Negative 15y plus negative 10y is negative 25y. And negative 30 plus negative 20 is negative 50. Divide both by negative 25, and I see that y is equal to 2. Well, all we have to do now is plug this into the other equation, and we'll be ready to go. Let's see, negative, wow, that's not good. I'm going to choose this one. Negative 4x minus 5y equals negative 10. I know that y is equal to 2. So that means that this y right here is 2. So negative 4x minus 5 times 2 equals negative 10. Go to solve. Divide by negative 4, divide by negative 4, x is equal to 0. My ordered pair would be 0, 2, and this is the solution to the SOE. We've only got one more example to look at, and for this one, let's go down here. Here we go. The issue that we see here is the following. I can't just say add them, and I can't just subtract them, because when I'm comparing my variables on top of each other, adding and subtracting does nothing. And so then I start playing this little game of, well, gee, could I please change one of them? That's a 4x. If this was a negative 4x, that'd work, but can I change this into negative 4x with multiplication easily? No. Can I change this into a negative 3x with multiplication easily? No. And so if we look over here, we've got the same issue here with the negative 7y and the negative 10y. I can't change them into their opposite. I can't change this into positive 10. I can't change this into positive 7. So that way if I added them in together, it would cancel out. I can't do that easily. So instead, we need to change both equations. And we change them with multiplication in the same way. And I would recommend that pretty much you look at the two stacked on top of each other. If I turn both of these into 12 and negative 12, that would cancel out. If I turn both of these into positive 70 and negative 70, they would cancel out. And you go with the one that has the least amount of work. I could times this by 3, and I could times this equation by negative 4. So here's our new equations. There we go. Multiply this by 3 and we get 12x minus 21y equals negative 66. Please make sure that you multiply each part of the equation by this 3. Over here, if I multiplied it by 4, that's great, and that would work good for subtraction because 12 minus 12 would be nothing. I kind of like adding, though. Negative 4 times 3x gives me negative 12x. Negative 4 times negative 10 gives me positive 40y. And negative 4 times negative 26 gives me 104 positive. At this point, I'm going to kind of move this down here so we've got a little bit more room. And then I can write off to the side. Let's show the addition sign here. Let's add them together. 12x plus negative 12x is nothing. Negative 21 plus 40 is 19y. And negative 66 plus 104 is 38. So y is going to equal 2. And now we just plug it into one of our original equations. 4x minus 7y. Well, the y is a 2. We know that because of right here, right? Equals negative 22. Let's go solve. 4x minus 14, negative 22. Plus 14, plus 14. 4x equals negative 8. Divide by 4, divide by 4, and we see that x is equal to negative 2. So here we go, negative 2, 2. That's our solution, and that'll work.